Hey everyone, today we are going to finish up our lesson on indefinite integrals. And we're going to start in on example 5, and it says evaluate the following indefinite integrals. And part A says integral of pi minus 8e to the x dx. So we want to find the antiderivative of this. And let's go ahead and break this up. Let's use some rules that we used last video. And so we have the integral of pi squared dx minus the integral, let's go ahead and pull that 8 out, minus 8 the integral of e to the x dx. Now this first integral of pi squared dx, a lot of times people start kind of going crazy and it's like, well, what is the derivative of pi squared? Or what is the antiderivative of pi? What is pi? So let's think about that. What is pi? Pi is 3.14, and there's a lot more decimals. It keeps on going and going and going, but it's just a number. So if I was to do this to decimals, this is just the integral of 3.14 squared dx minus 8, the integral of e to the x dx. Now, we know that the antiderivative of a number, we just add an x onto. So this is really 3.14 squared x. So I'm just going to leave it as pi squared x minus 8. Now the question is, what is the antiderivative of each of the x? And so what we ask ourselves is the derivative of what function gives us e to the x. And hopefully this is one thing that you remember from Calc 1 that kind of got beat into your head over and over and over again. The derivative of e to the x is e to the x. It's always e to the x. Derivative of e to the x, e to the x. Derivative of e to the x, e to the x. So what function gives me the derivative of e to the x? It's just e to the x. So we get pi squared x minus 8 e to the x plus c since we took the derivative. Okay, so that is our first question. We just kind of thought about what we broke this up into separate pieces, and we asked ourselves what the derivative of what function gives me this answer. So what is this antiderivative? Okay, I'd like you to pause your computer and try this equation. If you need some basic derivatives, sadly my e to the x wasn't on there, so I couldn't have used this in the last function or the last problem, but I'll post this page. This is the formula sheet that I give out on the test, but it gives some basic derivatives over here in the left-hand side. So I'll leave that up while you pause the computer and you answer this question. All right, welcome back. Okay, so everyone gets a little scared when we see trig. So let's break this up into its components. We get the integral of cosine of x dx plus 5, the integral of secant squared x dx. And so what we're going to do is just come off to the side and have some scratch work. Hopefully I gave myself enough room. And the first thing I'm going to do is ask, what derivative gives me cosine of x? So the derivative of what function gives me cosine of x? And what I'm going to do is I am going to go to my little formula sheet. And if you guys have to memorize these, if you're not in the class and you're memorizing these, I am sorry. And I am just going to look for cosine of x, but I'm not going to look for the derivative of it. I'm going to look for it on the answer side. So I'm going to come over here and look, okay, what derivative gives me cosine of x? And it happens to be this one. The derivative of sine gives us cosine of x. So here, the derivative of sine gives me cosine of x. So sine of x gives me cosine of x. So the antiderivative of cosine of x is sine of x. So we're going backwards here. Then come down plus 5. And then I want to know the derivative of what function gives me secant squared x. So I'm going to go look, see if it's a basic derivative. It's like looking. Okay, and here I have the derivative of tangent gives me secant squared x. So the antiderivative, oh, let me write that down. I'm notorious for talking before I write things down. So the antiderivative of secant squared x is tangent. So if I'm going backwards, I get 5 tangent of x plus c. And did I put a plus c on my first one? I sure did. Okay. Sometimes I will do a problem or two and realize I forgot my plus c's. So we have to go and backtrack. So that's a way that we can use our formula sheet where we have the derivatives here and we have the answers and we're kind of working backwards. And what we're doing over here is I'm really taking the integral of both sides. So I have tangent of x equals the antiderivative of secant squared x. Oh, and I did not give myself enough room to write dx. For those of you on the internet, I am not a professional video taker, so I apologize for the quality of my videos. And for my students too. Okay. So if you guys have any questions after these first two problems, this is kind of to get us back into the groove of things. Please send me an email. Please put a message on Canvas or put a comment on here on this video. Just let me know if you have any questions at all. All right, so let's move on. And we have evaluate the following indefinite integrals, and we have the integral of 12 cosecant cotangent plus 5x dx. Okay, so I'm going to bring this 12 out like normal. So I have 12, the integral of cosecant of x cotangent of x dx plus the integral of 5x dx. Okay, and I know that one of the normal questions is, why am I not separating this first piece into two integrals? Well, notice that these are being multiplied. And just like in derivatives, when I have that multiplication, I can't just separate them into two separate integrals. I have to treat it as one whole one. And later on during the semester, we'll learn how to deal with the multiplication when it's not a basic derivative. Okay, so we have these set up. And the first part that I'm going to do, here's my scratch work off to the side, is what derivative gives me cosecant x times tangent of x. So what derivative should I be looking for? And go back to that basic derivative sheet, and we're looking for cosecant cotangent. Well, notice I almost have it. I have the derivative with respect to x of cosecant of x equals negative cosecant cotangent. So I'm going to come down here and write that. Write the derivative with respect to x of cosecant is negative cosecant of x tangent. And I'm going to just scroll off to the side so I have more room. Tangent of x. That is almost what we want. But on this right-hand side, I need a positive cosecant cotangent. Well, that negative is really just a -1. It's a constant, so we can move it across the equal sign without causing too many issues. Okay, so what I'm going to do is divide both sides by -1. And because we're talking about derivatives and a -1 can move in and out of the derivative sign, can move through taking a derivative and out of derivatives, like we can move a constant in the integral and out of the integral. This is fine. So what I get is the derivative with respect to x of negative cosecant of x is positive cosecant of x tangent of x. Thus this little negative cancels out. Okay, so to answer our question up top, this is negative cosecant of x. Whew, that's a lot of parentheses there. So for this first one, we get 12. Oh, 12 times negative cosecant of x. And now we're going to look at that 5 to the x piece. So I'm just going to come along the side again and do more scratch work. And what I'm looking for is what derivative, or the derivative of what function gives me 5 to the x. Let's go to our handy dandy cheat sheet, looking for something that would be 5 to the x. Something that's really, really close is this one right here, where the derivative of a base to an x is that base to an x ln of b. And I'm going to write that down. So the derivative with respect to x of 5x is 5x ln of x. But the problem is right here, I only have 5x. I need to get rid of this ln of x. That's kind of in my way. Oh, not ln of x, ln of 8. What am I doing? That's what I get when I don't flip back to the formula sheet. ln of 8. 5. Man, guys, sometimes it helps if my brain works. Okay. So formula sheet, just to clarify, says our base raised to the x ln of our base. Base to the x ln of our base, and our base is 5. I do apologize for confusing you. Okay. However, the problem is I just want that x to the 5. Well, ln of 5 is just a number. We can type it into our calculator. It'll give us a number. So that means I can just divide it through. So I'm going to divide by ln of 5 on both sides. My ln's of 5 cancel. Since this is a derivative, I can bring that ln of 5 into the derivative, or I can stay out of the derivative using our derivative rules. And so the derivative with respect to x of 5 to the x over ln of 5 is 5x. So when doing our integral, what we were looking for is what the derivative of what gives me 5x, because this blue thing right here is the derivative, and I'm trying to undo it. I'm undoing a derivative. Well, the undoing of our derivative is 5 over ln of 5. So going back up here, and so we have 5 over ln of 5 plus c. And guys, something I suggest doing on your test is just at the very end, going back and making sure any of your antiderivatives have that plus c, any of your integral signs have a dx associated with them, or a dy, or a d, whatever variable we're working with at the time, just to kind of make sure everything is up to par. Okay, so I'm just going to simplify this a little bit further. I'm going to do negative 12 cosecant of x plus 5 over ln of 5 plus c. Okay. And this is where I would ask my class any questions. Where did I lose you? Since you guys are online, you're going to have to communicate that to me. Leave a comment, email me, any of these things. But I really need to know if you have questions, just because I'm talking to a computer right now instead of a class full of 50 students. All right. So question D, go ahead and pause your computer. Try this problem. I'll bring up the formula sheet in case you want to use it. All right, so go ahead and do that. Oh. All right, welcome back. So now we can do this problem together. And I'm just going to rewrite this, but I'm going to bring out my 5. 5's just a constant. Sometimes it's easier to see my antiderivatives when I do this. So I have the integral of 1 over 1 plus x squared dx. Okay, so now that I have my 5 out of there, I can go look at my formula sheet. So 1 over 1 plus x squared. And this AI assistant is getting on my nerves. Okay, so notice this very last one. We have the derivative of tan inverse is 1 over 1 plus x squared. So I'm going to come off to the side. The derivative of tan inverse of x is 1 over 1 plus x squared. So just to keep reiterating this, what we are doing when we take an integral is we are finding the antiderivative. So we have the derivative, and we're going back to find that original function. So my original function is tan inverse. So I get 5 tan inverse of x plus c. All right. Please let me know if you have any questions, comments. So now scrolling down to example 4. So example 4 continued. These next two are a little tricky. And you'll see why here in a second. But again, evaluate the following indefinite integrals. E says the integral of 5 over cosine squared dx. Okay, so going to do some manipulations here. I get 5, the integral of 1 over cosine squared x dx. And I want to know what derivative gives me 1 over cosine squared. So d dx of what gives me 1 over cosine squared x. Let's go look. Basic derivatives, 1 over cosine, 1 over cosine. There's 1 over x. I see sine, secant, cosine. I don't see a 1 over cosine. Great. So what this means is we need to do a little bit of algebra manipulation. So we need to do some algebra, or some trig in this case. So what I'm going to do, I'm going to cross off this because that wasn't very helpful, is the only thing I can think to do with this cosine on the bottom is bring it up. And remember, a cosine on the bottom is a secant on the top. So I get 5 the integral of secant squared x dx. All right. So now maybe the derivative with respect to x, the derivative of what is secant squared x. Now, some of you know these off the top of your head, and that's perfectly fine. But if you don't and you're kind of using the formula sheet more, that's why I keep bringing the formula sheet up. So secant squared. Hey, if we look right here, the derivative of tangent is secant squared. So the derivative of tan x is secant squared x. So that means the antiderivative of secant squared is tangent. So I get 5 tangent of x plus c. Okay, so sometimes when we look at a problem, we won't see the basic derivative reflected completely. Sometimes we have to do a little bit of algebra work. This one wasn't too bad. There was only really one thing that we could do, which was move that cosine up. Sometimes there are more problems that we kind of have to look at and we have to move things around. So I'm going to say pause the video and try F. F is a little bit harder than the one we just did, but I'll bring up the formula sheet so you can look around. All right, so pause the video, see if you can do this. All right, welcome back. Okay, so we have the integral of sine of x divided by cosine squared x. Do not write this down. Do not write this down. Okay, so if we do what we just did, we get the integral of sine of x secant of x dx. Secant squared. Secant squared x dx. Now, some of you do know the antiderivative of this, just because your calc teachers had you memorizing this, and some of you don't. So what we would ask ourselves is, what is the derivative or what derivative gives me this function? Go here. I had a sine and secant squared. I see secant squared, but not attached to a sine. I see a secant and a tangent that has a secant in it. So let's see if we can manipulate it to get to one of these two. That's kind of where I'm trying to go. So we can't really do much here. So what I'm going to do is I'm going to erase this. Feel free to just cross it out. You should have enough room. And so we have I'm going to break this up into two. And I'm going to do sine of x over cosine of x times 1 over cosine of x. Okay. This 1 over cosine of x gives me my secant that I just had. But this sine over cosine gives me something else. It gives me tangent. So the integral of tangent of x, oh, I forgot my dx. There we go. Times secant of x dx. Now let's ask yourself, the derivative of what function gives me tangent of x times secant of x? Let's go see if that's an antiderivative. Hey, there's secant and tangent right there. And the derivative that gives me that is secant. Okay. So I get the what derivative gives me this function is secant of x plus c, and we're all done. This one, I make it look a lot easier than it is because I know the answer. I've been doing this for a lot longer than I'd like to admit, but it takes some playing around with. What I typically look at is when I move that first up and I saw I had a sine and a secant squared, is I look at them and I was like, okay, the only one with a secant squared is just secant squared. It does not have anything attached to it, so it can't be this tangent. This other one, my brain goes, so I kind of ask myself off to the side, does sine of x secant squared x, does it equal tangent of x secant? Whoa, sorry about that, guys. Again, not a professional videoer. Do those two equal? They happen to equal, but the reason I chose this one is it's on my basic derivative sheet. It's like, can I manipulate this left-hand side to equal that? And it can if I change this to sine of x times secant of x times 1 over cosine of x. And then I group this sine of x and cosine of x for a tangent. Again, this takes a long time to develop, and you just kind of keep tinkering around. Hopefully in pre-calc, you had a lot of work with trig identities and being able to manipulate one identity into the next. And so that's kind of what we're doing here as we're starting with this. It's like, can it equal tangent of x, secant of x? I don't know. Let's try. And when you get it there, you can show it in your work over here. Does this equal this? And it does. Actually, I'd probably put a big old check mark there. Okay. So this is about as tricky as they get for this particular lesson. I promise down the road we'll add in some more algebra or trig trig identity changes that we need to do. But if you have any questions, let me know. All right, let's move on to this last problem, example 6. Robert wants to solve the integral of x sine of x dx. He gets the integral of x sine of x dx equals negative 0.5 of x cosine of x plus c. Now, sometimes I like to know what in the world is Robert doing? How did he get there? And to me, I just kind of write off to the side. It looks like Robert just use the power rule. On the x squared, or on the x, to get x squared over 2. Oh, he also just integrated sine. So the integral, okay, let me write this a little bit nicer. So the integral of x squared dx gives me x squared over 2. So the integral of x dx gives me x squared over 2, which is this first part. And then what he did was the integral of sine of x dx equals negative cosine of x. So he just integrated these pieces separately. We do not have a rule that says that. Notice that any of these that were being multiplied, we had to find an antiderivative that looked like it, or a derivative that took on that form. We do not have a derivative that takes on the form x squared cosine of x. So in these basic derivatives, I don't have an x cosine. I got secant tangent, cosecant, cotangent. I don't have anything that looks remotely like that. So Robert, you're wrong. Feel free to get as blunt as you want to. Robert, you're wrong. You can even take the derivative of his work, because this should, if you take the derivative, should be this. And remember, we have to use, because there's multiplications, we have to use the product rule, which would give us x negative x cosine of x plus 0.5 x squared sine of x. Okay, so if I took the derivative of this piece, I get this. They're not the same. So Robert, you're wrong. If we find the derivative of negative 0.5 x squared cosine of x, it does not equal x sine of x due to the product rule. Okay. The next thing I would probably point out is there is not a basic derivative that looks like x. Oh, yeah, x sine of x. So there's nothing that looks like this. Um, Even with some algebra. So we can't find the antiderivative. Find the antiderivative. And I'm going to put yet. By the end of the semester, we will be able to find the antiderivative. All right, guys, this is the end of this lesson. If you have any questions, please feel to let me know and email me.